Look around you for a moment. The ground beneath your feet feels solid and still, but it isn't. The Earth is spinning at nearly 1,600 kilometers per hour. At the same time, it's racing around the Sun, which itself is spinning and moving through the Milky Way. Our galaxy is rotating, along with billions of others, all woven into the vast structure of the universe. And if we zoom in instead of out, we find that atoms spin, particles spin, and even empty space is alive with motion. From the smallest scales to the largest, everything in the universe seems to be rotating. This raises a deeply unsettling question. Why? No one pushed the universe. There was no giant hand that reached in and started everything spinning. And yet, rotation is everywhere. Today, we're going to explore this mystery by following the clues hidden in everyday physics, cosmic evolution, and quantum mechanics, until we reach an idea hinted at by Richard Feynman, one of the most brilliant minds in science. By the end of this video, you'll understand why spinning isn't just something the universe does. It's something the universe cannot avoid. When scientists first began studying the universe, one thing quickly became clear. Nothing likes to stay still. Planets rotate on their axes. Moons spin as they orbit planets. Stars rotate, and entire galaxies swirl in massive spirals across millions of light years. Even objects that appear motionless are secretly moving through space at incredible speeds. The mystery isn't that things spin today. The mystery is how they started. If we rewind time all the way back to the Big Bang, the universe began in an extremely hot, dense state. There were no stars, no planets, no galaxies, just energy and particles expanding outward. So where did rotation come from? Why wasn't everything perfectly balanced, expanding smoothly without any twist or turn? The answer begins with one of the most important laws in physics, the conservation of angular momentum. This law states that once an object is rotating, it will keep rotating unless something acts to stop it. Angular momentum doesn't disappear. It can be redistributed, concentrated, or spread out, but the total amount always stays the same. This single principle explains an astonishing amount of what we see in the universe, but it also creates a deeper problem. Conservation explains why spin persists, but not why it existed in the first place. To understand how small rotations become large ones, imagine an ice skater spinning on the spot. When their arms are extended, they rotate slowly. When they pull their arms inward, they suddenly spin much faster. No extra energy is added. The spin simply becomes concentrated. This same physics governs the birth of stars and planets. In space, massive clouds of gas and dust slowly collapse under gravity. Even if that cloud has the tiniest amount of rotation, so small it seems insignificant. As the cloud shrinks, it spins faster and faster. Over millions of years, that faint motion becomes a rapidly rotating star. The leftover material forms planets, moons, and asteroids, all inheriting the same spin. Galaxies form the same way, on a much larger scale. Vast regions of matter collapse, amplify their initial motion, and settle into rotating structures. What's remarkable is that the original rotation doesn't need to be strong. It only needs to exist. Gravity does the rest. But this brings us back to the central mystery. Where did that initial motion come from? Why wasn't the early universe perfectly motionless? Richard Feynman approached this question in a completely different way. Instead of asking why the universe has motion, he asked why we would ever expect it not to. Perfect stillness, he pointed out, is an extremely special condition. For something to be completely motionless, every tiny movement would need to cancel out exactly, and nature almost never produces perfect cancellations. At the smallest scales, quantum mechanics tells us that motion is unavoidable. Particles constantly fluctuate. Energy jitters. Even at absolute zero temperature, particles refuse to sit still. The universe, from its very beginning, was never calm or symmetrical. It was full of tiny irregularities, microscopic imbalances that created motion in every direction. Once motion exists, physics fiercely protects it. Angular momentum locks it in place. Over time, gravity magnifies it. According to Feynman's way of thinking, the real mystery isn't why the universe spins. The mystery is why anyone would expect it not to. Motion is the default. Stillness is the exception. As strange as cosmic rotation is, the story becomes even more mind-bending when we zoom down to the quantum level. Electrons spin. Quarks spin. Photons spin. But unlike planets or stars, this spin isn't caused by physical rotation through space. It's intrinsic. An electron doesn't spin because something made it spin. It spins because that's what an electron is. Physicists once tried to imagine particles as tiny spinning spheres, but that idea quickly fell apart. The math didn't work. Instead, quantum spin turned out to be a fundamental property of reality, like mass or electric charge. Even a particle floating along in empty space still carries angular momentum. This leads to a staggering realization. Rotation isn't just something that happens in the universe. Rotation is part of the universe's underlying structure. The equations that describe reality are built on symmetries, rotations, and conserved quantities. Spin is not an accident. It is a rule. Feynman loved this idea because it suggested that the universe doesn't need a cause to rotate. Rotation is woven into existence itself. When we put all of this together, a clear picture emerges. The early universe contained tiny quantum fluctuations. Those fluctuations created motion. Angular momentum preserved that motion. Gravity amplified it. And nothing in the laws of physics is capable of completely removing it. There is no universal mechanism that says everything must stop spinning now. Even black holes rotate, dragging space-time itself along with them. On every scale we can observe, the universe keeps turning, twisting, and swirling. From Feynman's perspective, nature doesn't require a reason to move. Motion is natural. What requires explanation is stopping, and stopping is incredibly difficult. That's why the universe is full of spin, and always will be. Right now, you are part of this endless motion. You are spinning with the Earth, moving with the sun, traveling with the galaxy. Inside you, atoms vibrate and particles carry intrinsic spin. You are not separate from the universe's motion. You are one of its patterns. Stillness is an illusion created by perspective. Motion is the truth underneath everything. And once you understand that, the universe stops feeling like a static place and starts feeling alive. The universe didn't choose to spin. It had no choice.